Next time you go out and have dinner or lunch with friends, then you can crack open your own tip calculator and figure out the final bill. So I hope you had fun building this project and doing all of the coding exercises and learning about mathematical operations, f-strings, data types, type conversion, and all of the things that we did today. Hey, you've completed day 2. So you haven't just done one lesson, you've actually done 2 now in a row, which is fantastic. And in fact, you are now above 50% of all the people who start something and never finish. But I know you. I know you're not one of those people. I know you're going to keep going and you're going to get this in the bag. So keep going, have a rest, have a good night's sleep, and I'll see you bright and early tomorrow morning. Hey guys, welcome to day 3. Today you're going to learn all about conditional statements, if, else, elif, logical operators, code blocks, scope, global and local namespacing, and a whole lot more. And by the end of the day, you will know enough to be able to build this awesome choose your own adventure game. So this is what it looks like when it loads. And our mission is to find the treasure. So it tells us you're at a crossroad. Where do you want to go? Left or right? Let's say I want to go left. You come to a lake. There's an island in the middle of the lake. Type wait to wait for a boat. Type swim to swim across. I'm going to wait for a boat. You arrive at the island unharmed. There's a house with 3 doors, 1 red, 1 yellow, and 1 blue. Which color do you choose? Let's choose red. And unfortunately, it's a room full of fire. Game over. So this game lets the user make decisions, and depending on what they've chosen, it continues the game storyline. If you want to have a go at this game, you can head over to treasure-island-end.appbury.repl.run and have a play around with the game. And once you're ready, head over to the next lesson, and we're going to start picking up the skills that's going to be required in order to build this game. So I'll see you on the next lesson. Here's a question. Have you ever sat in your bath and wondered, why is it that no matter how forgetful I am, my bath never overflows like this? This is something I was thinking about the other day. And I realized that it's not because I'm particularly diligent. I forget stuff all the time. I mean, pizza, anyone? It's what my pizzas usually look like. But the reason why our bathtub or the sink doesn't overflow is because of this fantastic piece of engineering, the overflow. So this means that whenever the water reaches beyond a certain level, about here, the water starts overflowing so that the bathtub doesn't overflow and annoy your neighbors downstairs. In fact, we could represent this mechanism with a conditional statement. When the water level is, say, greater than 80 centimeters, then it should drain the water. But if the water level is not greater than 80 centimeters, it should continue filling up the tub. This type of conditional statement is known as an if-else statement. Depending on a particular condition, we would do either A or B. And when we want to write Python code to represent this, it looks something like this. There's the keyword if, and then the condition that we're testing for, and then a colon. And after the colon, we've got an indented block of code which should be executed if this condition is met, if it's true. But if it's not true, then we will skip to the else block, and it's just the else keyword with a colon. And then this code block would execute if the condition is false. So we could represent that previous bathtub situation with code that looks a bit like this. Let's say our water level is at 50 centimeters, and then we would test if the water level is greater than 80 centimeters. Well, if that is the case, then we should drain the water. But if it's not greater than 80 centimeters, in other words, else, well, in this case, we should just continue filling up the bathtub. Let's put this into practice with a real life problem. Now, let's say that you've gotten a job at a theme park, and your first job of the day is to write some code that replaces the ticket box. Now, there's a couple of things that you'll need to think about. Firstly, in order for somebody to actually purchase a ticket to go on the roller coaster ride, they will need to be over 120 centimeters. So we have to check what their height is, because if they're too short, then we won't be able to sell them a ticket anyways. In the course resources, I've included a link to this flowchart that I've created on draw.io. This is a really useful tool for creating any sort of flowcharts or diagrams, and it's really easy to use. Now, if we take a look at this flowchart, this is basically the logic that we have to program using our if and else statements. If the person who's trying to purchase a ticket is not over 120 centimeters, then they can't ride on the roller coaster. But if their height is greater than 120 centimeters, then they can ride. So let's try it out. If you head over to the starting replit, you'll find some starting code in there, and you can go ahead and fork this replit. All that I've got here is a print statement that says welcome to the roller coaster, as well as an input asking the user for their height in centimeters, and then converting this string into a whole number, an integer. And then I'm storing it inside this variable called height. Now we're going to check whether if the height that the user has typed in is greater than 120. So we use the keyword if, and then we check if the height is greater than 120
or equal to, right?
And then we add the colon. And now when I hit enter, you'll notice
automatically
that
tabs it
the
over.
code editor has automatically indented me slightly over. I'm not over here, because in Python, the spacing and indentation is really important. It tells the computer that the code that I'm about to write is what should be executed when this condition is met. So what should happen? If your height is over 120, then we will just print you can ride the roller coaster. But what should we print if height is not greater than 120? Well, in this case, we would use the else statement to catch when that happens. And it's really important that you don't write the else here, because this is indented over. Instead, you want it to be at the same indentation level as the if statement. These two are essentially a pair, if and else. Now, after the else keyword, we again add a colon, and then we hit enter, and we're now indented again. And here we can write the code that should happen if this condition is false. Sorry, you have to grow taller before you can ride. So the really important things here are the condition, which we're testing for, is the value of height greater than 120, the syntax of this code, so the keywords if and else, as well as the colons that come after each of these lines, and finally also the indentation. Everything that is indented after the if is a block of code. So this is indented, and it's effectively inside this if. So this line of code lives inside the else statement. This block of code lives inside the if statement. And if you mess up on the indentation, then you're probably going to get an indentation error telling you that this line, 5, probably should be indented. But when we do actually correct it and we hit run, let's say that our height is 130 centimeters. Then we get back, you can ride the roller coaster. But if our height was, say, 90 centimeters, then we get a different outcome. We get, sorry, you have to grow taller before you can ride. So by using if and else statements, we're able to get our code to do different things, either printing this line or printing this line, depending on a condition that we're testing for. Now, when we use this greater than sign, effectively what we're saying is that is the height greater than 120, which means that it does 120. In fact, if I run this code and if I type in my height as 120, then it actually goes into the else block and prints this. So if we wanted to include 120 centimeters so that all the people who are exactly 120 centimeters can ride the roller coaster, then instead of just using a greater than symbol,
equal to,
we have to write greater than or equals. So these two symbols have to be next to each other. And now when I run my code and I write 120, you'll see that it's now falling into this block of code and it's telling me that I can ride the roller coaster. Now these are called comparison operators, and we've already seen greater than, so lesser than is pretty self-explanatory, but we've also seen greater than or equal to and lesser than or equal to. So if you want to include a particular number or a particular value, when you do these comparisons, you would be using these instead. Now in this table, there's also the equal to and not equal to. For example, if you wanted to check if somebody's height is equal to precisely 120, then you would use two equal signs. And very often it gets a little bit confusing, especially if you're new to programming, when you're typing equal signs, because sometimes we're typing 1 and other times we're typing 2. It's important to remember that when you have one equal sign, it means that you're assigning this value to this variable. But when you have two equal signs, you're checking to see if the value on the left is equal to the value on the right, and they're completely different. Now, the good thing is that when you get it wrong, usually you'll get enough clues in the error to actually hint to you, hey, maybe there's something that's wrong here, right? Because the syntax doesn't look right. For this to be a condition, it has to be something that evaluates to true or to false. And height equals 120 does not evaluate to either. So by changing it to this, we're saying if height is equal to 120, then we'll execute this line of code or any other lines which are in the same block of code. But if the height is not equal to 120, then we're going to execute this block of code. So by changing it to this, we have 120, which just flips it around, then a roller coaster. By using if and else statements, we can get our computer to do different things and respond differently depending on different conditions. So in the next lesson, alright guys, it's time for yet another code challenge to test and see if you've learned what was covered in previous lessons. So head over to the assignment that is day 3.1, odd or even. Have a read of the instructions and try to see if you can create a program that checks whether if a number that you input in the console is odd or even. Now, the thing to remember here though is that we're introducing something called the modulo, and you can create the symbol by simply typing the percentage sign. Now, what the modulo does is it will divide a number, say 7, by another number, let's say 2, and then it'll give you the remainder of that division. So 7 divided by 2. 7 split into portions of 2 is 2 plus 2 plus 2 plus 1, right? So 7 divided by 2 can be divided 3 times with a remainder of 1. And that's what the modulo gives you. So you can also type code straight into the console, like I am going to do now. 7 modulo 2 gives me 1. Now, it's the same thing if you try to divide by other numbers. Let's say 7 modulo 3, well, that is 3 plus 3 plus 1, right? So 7 modulo 3 will also give me 1. So this is a way for us to divide a number by another number and get the remainder. And you're going to be using this modulo to solve this code challenge. Have a read of the instructions, have a look at the examples, and see what it is that we're expecting to be printed in the console here.
Write out a program that works whether or not even numbers can be divided by 2 with no remainder. Wait, what? Oh, 3% to run. So, if number greater than 64, if number is greater than no modulo if pair number greater than 2. Else I need a colon, don't I? What the fuck did I just hit? Wait, why is this so far up? Else friends or number. Fuck out of the way. Yo, Brian Nice. Okay, I think that does it, but I don't think the what I have is written the way it wants to. Okay, this is an even number is the way it needs to be written. This is an even number. The fuck is that? Give me. Where's the code room? This is an odd number. This is an odd number. Okay. Copy. Coding room. Yay! Well, that was an easy coding room.
And then go ahead and write your code and see if your output matches what it is that we're expecting. So 56 should be even, so you should be printing this is an even number based on that input. Pause the video now and give this code challenge a go. All right, so I mentioned that the modulo gives us the remainder, right? So what do we know about even numbers? Well, even numbers, they're always divisible by 2. If we pick any even number, say 54, and then we do modulo 2, so 54 divided by 2, it should always give us 0 as long as that first number is even. So 68 modulo 2, again it's 0. But then when we come across an odd number, say 53 modulo 2, then even like a number, well in this case, then we can pretty much be sure that this is an even number. Because as we've
Hi,
shown,
kitty.
all the even numbers, when they divide by 2, there's always no remainder. So in this case, let's add a colon. We can print pretty confidently that this is a even number. Now, what about the cases where the number, when divided by 2, is not equal to 0? Well, then it's probably going to be an odd number. So in this case, we can use an else statement to catch that. And when we have an odd number, we'll simply print this is an odd number. So that's it. Just 4 lines of code using what we've learned about if, else, and also the comparison operator. Now, if you got stuck on this and you needed to watch the solution, then I recommend really going back to your code and playing around with it so that you can get the code to work. And then, where we're going to talk about even more complex ways of using if and else statements. So for all of that
Nesting.
and more, I'll see you there. In previous lessons, we learned about using the if and else statements to check whether if somebody is over 120 centimeters or not, and allow them to actually purchase a ticket if they are over a certain height. Now, in addition to the height, there's another condition that we need to check for, namely their age. If somebody is over 18 years old, then they should be paying the adult price, which is, let's say, $12. But if they are 18 or under, then they should.
Shit, I forgot my phone. I'll be right back. Oh. What does that even mean? Hey, can you quit fucking fighting at the microphone? Oh. Cause there's no, I don't think there is a Python category. There's no programming category. There should be a programming category. There was one at one point, but there isn't anymore apparently. Is there a Python category? Nope, just a Monty Python and Funky Python.
Only be paying $7. So, how can we represent this extra condition that we need to check for in our code? Well, we could use something called a nested if-else statement. We've seen our if-else statements look like this, where
Competitive
it's only
programming
got
ranked top
two
500
choices.
when.
If this condition is true, do this, otherwise do that. But in a nested if statement, once the first condition has passed, we can check for another condition. And then we can have another if-else statement inside this if condition. In order for this thing to happen,
This first one
this
needs to
has
be
to be
met.
true and this also has to be true. In order for this to happen, this condition has to be true,
This
but
one
this
has to be
condition has to be
false.
false. So essentially, the computer first looks at the larger picture, which is this first condition, and decides on whether if it should go into the else block here, or if it should go into the nested block inside the if statement. So now this is what our flowchart looks like. In the first if statement, we check whether if their height is over 120 centimeters. If no, then the if statements all end. You can't ride, you can't buy a ticket.
So go
But
fuck
if
yourself.
yes, we actually take them to yet another if statement where we check their age. If their age is 18 or under, then we give them a $7 ticket. If they're over 18, then they have to pay $12.
What a fucking ripoff.
So the place where we're going to nest our if statement is inside here. Notice how it's indented, so it's already inside this if block. And this
And then
already has to be true. Now here we're going to create another if and else statement. And the condition checks for their age. So we better ask them for an age. Let's say age equals, convert the input to an int, and what is your age? So
What
now that
is
we've
your
gotten
name?
hold of their age,
What
we can see
is your
if
quest?
their age is less
Oh my
than
god, I'm
or
so gonna make
equal
that as
to
a program.
18, well, in this case, we're going to give them the $7 ticket. But else, namely, if this is not true, if their age is over 18, well, in that case, we're going to give them the $12 ticket. So now we have a nested if statement, because this if and else statement lives inside this if statement. So this condition will only be checked if this is already deemed to be true. Now let's say our situation got a little bit more complex.
Oh,
The boss
Jesus.
comes over, checks our code, and says, wait. There's actually more price tiers than that. In fact, if you're less than 12 years
What are you
old,
freaking out about?
you pay
What?
$5. If you're between 12 and 18, you pay $7. And if you're over 18, then you pay the full adult price, which is $12. Now, there are
That's some
three
bullshit.
possibilities. So how do we represent this in our if statement? Well, we could use something called the elif. Instead of having a simple if-else statement where there's only one condition, if it's true, do this, otherwise do that, you can add as many elif conditions as you want. So we can check for condition 1. If that's true, then do A. But if that's not true, then we can continue and check for condition 2.
That's what
If
an elif
condition
is.
2 is true, well then we can do B. And finally, if none of those conditions were true, we can do this final thing. Our flowchart now looks something like this. And this is the logic that we're trying to program. Once we're inside this nested if statement, we're going to check if their age is under 12, in which case they should pay $5. If they're between 12 and 18, then they should pay $7. And finally, if they're over 18, then they should pay $12. Now, the first thing I'm going to check is if the age is less than 12. Under this condition, they should pay $5. So let's change that to 5.
And the elif.
Now, the next condition should be created using an elif, which stands for else if. So it means if this is not true, else if, can you check if this is true? Well, in that case, then we should do this. For example, if the age is not less than 12, so they're over 12, then are they under 18? Well, then this condition basically catches everybody who's between 12 and 18. And finally, if they're not less than or equal to 18 and they're not less than 12, then that's everybody else who is over 18. Now, remember that we can use as many elif conditions between the if and else as we like. So I could add another elif that checks whether if the age is less than, say,
One.
22. Well, in this case, do something else. And then I can keep going with these elifs until I'm done with all my conditions. So have a play around with this code, write it yourself, see if it makes sense, and then mess around with the elifs so that it does what you expect it to do. And then once you're ready, go ahead and head over to the next lesson where I've got a
BMI
coding challenge for you.
2.0. More BMI shit. Mine's not
So
even a
now
good
that you've
fucking.
learned all about if, elif, and else, as well
I'm gonna
as
say you
nested if
fat.
statements, then I've
I
got
live.
2 code challenges coming up for you.
What?
In the first one, in the code challenge that's called Day 3.2 Bmi Calculator 2.0, this is going to be an upgraded version of the BMI calculator that you created yesterday. Instead of just working out the BMI value of somebody, we're going to give them an interpretation. You might have
You're
come across a
clinically
BMI
obese.
chart that looks like this, where it divides up people's BMI and tells them whether if they're underweight, normal weight, overweight, etc. And this depends on the value of the BMI. So if the value of the BMI is less than 18.5, then they are underweight. If they're over 18.5 but below 25, then they have a normal weight. So your job is to not only create a BMI calculator, but also to give them the corresponding interpretation message. Now, it's really,
Oh.
really important that you use the words here that are highlighted in bold in your interpretation, that based on a particular height and weight, you actually give them the correct interpretation. Pause the video and try to give this.
BMI Calculator 2.0. Fuck. On. First, I need to go find my old. I fucking did it before. Files. Home. This is my death chart. There we go. Happy. Paste. Okay. Oh, shit, I made them floats. Fuck me. God damn it. There's extra work I just did in there. I didn't have to. But I could have just done. Nope. That didn't work. I guess I wouldn't be 5 meters tall, would I? 1.237. Okay. Okay, so that does work. Okay. So it's the BMI. Now, where's the instructions? Oh, here it is. If your BMI is 18, you are underweight. That equal to, or yeah. What is the measure? Student. Sign in. LCC. Password? That works. Now, where's the software? Where the fuck? What's info path? Microsoft server for students. Huh. What's this? Select a certificate. Is he online now? I guess it is. Doesn't exist there yet. How did I download this shit from? Remote Learning OS. Ah. Product keys. Here we go. Let's isn't it either. God damn it, where was this? Education Center, here we go. Yeah. The fuck is that? I need from a while back. Where did it go? I need history from longer back than that. Maybe this? Where'd my history go? Software. There we go. Can I just bookmark you, please? Bookmark T? The fucking time I found that fucking Jesus Christ. Preparing for first use. I didn't even put it on a place for my fucking. Okay. Oh fuck. So I don't know what the fuck the point of having this Enterprise Edition is, but I like that I can get it from school I don't go to for free. All right, so now that I have that, and this is probably vastly overkill for what I'm doing. Close. Don't save. What kind of documents my recent apps, huh? Calls. Why in the fuck did I get 6 calls? What the fuck is this 888 number? Okay. So, where did I leave off? Now I can close all these fucking tabs. Now that I finally found what I wanted. SharePoint server, huh? Claim my Azure credit now. SharePoint server subscription standard. Windows 11 Education Edition. What else did I get? Other free software comes with shit. Okay, where is it? Oh, I need to do BMI thing. New. Python application. Toolbox. I don't even know what that is. No world. Okay. Build failed. Why did my build fail? What does that even mean? To resolve this, install developer pack, SDK targeting pack for this framework version. Done building project Python. Yeah, it seems like that will work. Okay. So let's just see if this runs the right way. Start. Some Unicode characters that could not be saved during the code page. Do you want to resave this file? No. Run it as is. Okay. Cool. Oh, well, that's handy. Exit. Erase all this. What does run code cleanup do? Environment. Holy shit. I don't even know what any of this means. Getting it over my head. Can I like create another thing in here so like within a project I could have all of my files from new file? Python. The module. Module 1. Is this saved within this project? Save? No. Don't save. Why don't I leave Visual Studio alone until I become somebody that could actually use it? I just got distracted for like an hour on this shit. Leave, 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 leave. Okay. Where did I leave off? Oh, yes, the Bmi Calculator, that's right. A3-2. What? What? So I need to be like near height in meters. 1.4, 1.5. Weight in kilograms. 45. BMI 20. Cool, 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 cool. Oh, that's where it is. That's where I opened it. So ba 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 B just gonna comment out these lines here. What should I do first? From the lowest or the highest? Okay, so an integer. If kind of cool. BMI. Uh, less than 0.5. Wait, isn't if? Don't I need a fucking thing?
In previous lessons, and this also
If
has a condition that we need to check for in our code. Well, we could
condition this, else less than 18.5 before. Does auto tab it over? No. Yes, it does. No, it doesn't. Print. Where's the fucking sample? Well, BMI is BMI. I need to use one of those F things, don't I? F. Your BMI is BMI, comma, you are underweight. Wait, was it comma? You are underweight. Eat a burger. Else. Else 1, 4. Print. Nothing. Boom. What? Syntax error. Why? Valid syntax. How is it valid? What makes it? Bmi flakes? Try 18. Run.
Use something as addition as passion. This and decide statement by a 12 block.
If BMI is less than, I need colons. That's why. Run. What's a fucking, how many meters is a person? 1.5 kilograms? Okay. 0.5. I can do this 0.5 now. Here we go. Are underweight. Now I can do over but below. Oh, that's confusing. Yo, what's up? BMI greater than 35. Yo. Kelly, obese. Eddie. No. Okay. Elif. Does that go on the same line? Elif. Below, over 30, but below 35. Fuck. Do I need to make LF statements for each one of these goddamn things? Like nesting LF statements? Oh, god damn it. Okay. I think I'm gonna have to look at the solution and see what they fucking do. Just to see if I'm on the right fucking track. If I have to write up nested fucking things with LF statements each time, I want to know, because I've already done these things the fucking hard way, writing like goddamn 15 lines or whatever, when they're like, oh, we can do it in one fucking line of code. I'm like, oh, Jesus Christ. Go fuck me. I don't have the answer for that. They don't even have a fucking, where the fuck is it? Yeah, I don't even know where the coding rooms. There we go. Exercise. Guys, here's the, okay, these are the, try to use the exponent operator in your code. What? How's that a hint? The fuck would I need an exponent for? It's BMI. Okay, I need to take a look at this shit. What the fuck are they talking about? Work this shit. What? Oh, okay, this is the testing. So where the fuck is an exponent? Oh, to create the fucking BMI thing. Okay. I've already created the BMI though. If, okay, so I was on the right page, but okay, so I got everything. But how did you do the between? I don't think this is right. Oh, I see. I would not have thought about rounding that. I was just being overthinking it. Okay. That makes sense. So instead of greater than, they use the less than for each thing. Okay, so I was on the right path the first time I started writing it, and I started overthinking it. It's less than 18.5. I left and you write on the same line? Yes. Over 18.5, but under. Okay, I see. So if I put 25 there, okay, so I had some, I was fucking doing all right. I just started thinking way too much about those two numbers. Oh, it was working, and I just started thinking about how the fuck I had to do two numbers there, and I was like, oh shit. But I guess you don't really have to worry about the one number because it's already thought about. Uh, I don't need a number there. I don't need a fucking parentheses. What I do need is a hold on. Print fuck statement. God damn it. What am I hitting? It's been a long fucking day. Your even though BMI isn't a good indicator of um weight, your body mass, because for lots of reasons. It's used just for statistics. What's this exact statement you have to fucking write? You have a normal weight. You have a normal weight. Period. Quote. Why do I have a fucking wait. Why do I have a fucking line 25? I don't have anything in line 25. Oh, I have too many fucking quotes there. So why is my LF statement not working? PY flakes. What the fuck's PY flakes mean? Oh, because I didn't put the fucking variable. $1.5, 25. Your BMI, okay. Wait, no, that's not working right. Your BMI is 11 point something. That should be less than 18.5. Shouldn't say you're clinically obese. You're severely underweight. Oh, because I have it written out. Are you sure you are clinically obese? I'm dumb. You are underweight. I was really confused there for a second. LF BMI less than. If I put below okay, 30. There we go. Print. Fuck you statement. Your BMI is BMI, comma. Get the fuck out of the way so I can read what I need to write. You are slightly overweight, even though this is incorrect. I need a quotation there. Period. God damn it, stop making two quotes. Stop making two quotes, you fuck. Okay, run. My fucking, how high is so many meters? Okay, good. So I needed to make this a round. That's just a function, right? Print. How do they put the function round like this? So nope, apparently not. Should put it around BMI. Okay, it's gotta go around the. Yeah, that's where I have it. Round, weight divided by. I'm not gonna get any syntax error then. What did I fuck up here? It's round. Put a space there? No, I don't even know. Does that work? The fuck? Error while scanning print literal. I have too many quotations there because it likes to fucking make two quotation marks everywhere. Your height, I don't know, 1.5, 40 kilograms. You are, okay. over LF I less than 35. Into fucking print. Fuck you. You are. Wait, did it go from slightly obese to? Oh, yeah, it does. You are obese. Stop making double quotation marks every fucking time. Else. Why is this giving me something? Why is it saying PY flakes? Else print. Fuck you. You are clinically obese. Failed syntax where? Oh, no quotation there. Fucking stop making double quotation marks. There we go. 1.5. 50 kilograms. You are of normal weight. 1.5 and 75 kilograms. You are obese. So I believe I have everything I need. I can go. That's an assignment workspace. Run. Score. What? How did I feel it? Expected. Oh, I fucking didn't put the phrasing right. Wait, yeah, I actually don't see where the difference is. I'm confused. Explain difference. Did not expect /n on line 2. I'm not following. This mean? No, don't. I'm confused now. Print. Oh. They have you print the Oh, because I had to print the BMI first. That's why. That's stupid. Just need to get rid of that line of code. Submit. There it goes. There we go. Dunzo. Well, that was annoying. But that's done now.
And try to give this challenge a go. Interpretation is equal to, though, just wait, we're going to use an elif, and over 35 instead of less, whether if a little bit mysterious to you. And hopefully, once you're done there, then...
What does that none mean?
Hey guys, so I've got another code challenge for you. And this one, as the title suggests, this is a difficult challenge. And this is something that I expect some of you might need to spend 15-20 minutes on, others might need to spend 30-40 minutes on, and it might just be something that you need to have a think about, get stuck, come back to it after a bit of a break, or sleep on it, come back to it the next day. It's not easy, but what I'm trying to say is really, really give it all you have before you check the solution video, because it's a really, really interesting challenge. So the idea is that we want you to write a program that works out whether if any given year is a leap year. We know that a normal year has 365 days, but leap years have an extra day in February. And the reason is actually really, really interesting. If you're interested, there's a really good explanation of how leap years work and why we have them at this YouTube link. So just go ahead and copy this URL and check it out. Now, the way that you work out if a given year is a leap year, so let's say we pick one out of thin air, 2020, is that on every year that is evenly divisible by 4, so that means divisible by 4 with no remainder, then that is a leap year. But except the years that is also evenly divisible by 100. Unless the year is also evenly divisible by 400. Now, 2020 divided by 4 is equal to 505. So it's evenly divisible by 4. There's no remainder. But the rule says that even if it's divisible by 4, if it's evenly divisible by 100, then that is still not going to be a leap year. So let's try that. 2020 divided by 100 equals 20.2. So this is in fact not evenly divisible by 100. So that means it is still a leap year. But then it says unless the year is also evenly divisible by 400. So 2020 divided by 400 is not evenly divisible. So it is in fact still a leap year.
Wait, what?
The trickiest part of this entire challenge,
I was trying to get your brain around that fucking...
getting your head around these 3 sentences. A year that is divisible by 4 with no remainder is a leap year, except if it's also divisible by 100. In that case, it's no longer a leap year. Unless that year also happens to be evenly divisible by 400.
You have to make 2 things and
then it is still a leap year. What I recommend doing is A, if English is not your native language,
go fuck yourself.
Have a look online for the rules for determining a leap year in your own language, because these words, except and unless, are so integral to how this algorithm works. So, and you really, really need to understand exactly what it means. Then what I recommend you doing is to go ahead and create a flowchart, just like what I've done in previous examples. Head over to a website like draw.io or simply just write it on a piece of paper, draw it out, and visualize what this actually means in terms of your code. Now, if you really get stuck on that, I've also created a flowchart for you. So if you actually get stuck creating the flowchart, there is one there that you can refer to as well. But it's a really good exercise creating your own flowchart based on what it is that you want your program to do. And your algorithm or your code should correctly tell us whether if it's a leap year or not a leap year. So it just has to print out leap year if it is like 2400, and if it's not a leap year like 1989, then just print not leap year. This is the time to pause the video and really give this challenge.
Oh, I wanna. What did she say? Draw.io. I've never been there. Apparently I have a save diagrams. But is this fucking? Am I signing in with something? Yep. Okay. Is this? What? No, I don't want to fucking do this on my Leaks account. Just use fucking Google Drive, I guess. Class diagram flowchart. No, pick a folder. And make new folder? Apparently not. Apparently that's not an option. Alright. Well, maybe I can just write one. Try Python food. Hey, that worked. Okay. No, it did not. It said go fuck yourself. And no items in this folder. Yeah, I know. Save them there. Dude, go to drive. New folder. You probably have to refresh this shit. Yep. Leap year. Bullshit. Yes, no, I want to save it in this folder. What don't you understand? Don't you understand? Yeah, the folder I want. Do I just select it? Select. Select. There we go. It's connected. How do you mind? I don't know anything about flowcharts. Like, is that what the? What is it supposed to mean? Like, um, should start here. Is it a leap year? On a year that is evenly divisible by
Every
four. Oh, content's divergent. We have a hard time resolving differences between your content and the server content while you're disconnected. I don't understand why that would happen. I don't want to say. On a year that's evenly divisible by four. Oh, year evenly by four? Question mark. Yes. No. That's a year. Yes. Is no. Can't just say it is a leap year. Fuck. See, yeah, that's where not knowing anything about flowcharts becomes a pain in the. If it's not divisible by it, then it's except. Okay. So I need to actually make it is divisible. On every year that is evenly divisible by four, except every year that is evenly divisible by 100. Unless the year is also evenly divisible by 4. Fuck this sentence. My brain is just like, eh. So is it divisible by 4? Yes. Therefore, it is a leap year. Except year is evenly divisible. So it's no. If not, it is not a leap year. But if so, but also it is divisible by 100, right? Or is it the other way around? Let her explain this again.
then what I reckon that here also happens to be. So let's try that. 2020 divided by 100 equals 20.2. So this is in fact leap year's work and why we have them at this YouTube link. So just go ahead and copy this URL and check it out. Now, the way that you work out if a given year is a leap year, so let's say we pick one out of thin air, 2020, is that on every year that is evenly divisible by 4, so that means divisible by 4 with no remainder, then that is a leap year. But except the years that is also evenly divisible by 100, unless the year is also evenly divisible by 400.
2000 is equal to, so it's, you have one thing that's saying it's a leap year, one thing that's saying it's not a leap year, but one thing that's saying it's a leap year. Well, which one is right then? So the 2020 is a leap year. Okay. Where do I see this text? Because I want to read the whole thing. I don't think it exists. Oh, wait, maybe here. No, okay. Okay. You know what? Fuck it. I'm just taking her thing. This will make more sense. For the curious how leap years work. Fork you. So, okay, this is how you make a flowchart. Okay. Let me recreate this so I actually understand how to make a. So you start. And then triangle means a decision, I guess. So is it a leap year? No, it's not a leap year. Alright. Abs. Yes. So yes does bring you to another flow part. Not another. Oh yeah, so this would have to bring me here. Okay, so she actually does put it up. This brings me to another decision then. And then this would have to bring me to another choice. Which is another, what the fuck? Triangle thingy. Where do I find it? Where are you? Should just copy and paste. How about that? Never mind. Apparently that's not gonna work. Copy, paste. Oh, there we go. How do I get an arrow? It's divisible by 4. No, not a leap year. Yes. Get rid of you. Oh, there we go. Yes. Divisible. I don't know if I'm spelling divisible right, but by, what was that, 100? Yeah, 100. If no, then leap year. Copy. Oh, I can, oh, that's nice. No, that's not the right icon. This one? Nope, still not the right icon. This one? Yeah, looks like. How do I label the between? How do I label the answer? No. Neo? Oh. Leap year. If yes, go ahead to copy it. Yes. Visible 1,000 was it? 4,000. 4 no by 400. So this one has 2 answers, so it has to have 2 squarey things. This one has these square things. If it was a no, then it's not a leap. Correct. Yes. That's here. Here. And move all this over. Yes, you can, except for I didn't grab the last part. Well, this is kind of a nifty tool. I might have to use this, like... Why does this still say disconnect? Save. Can I just, like, look at this in Google Drive? What did I call it? Oh, wait. Yeah, right there. What happens if I print that? What does it look like? Not bad. Cool. This will help with, like, when I'm trying to write up stuff for work for, what's it called? Um, I forgot. Live stream. If I can delete that shit. Move. Trash. What is this? So much shit in here and I have no idea what it is. Coinbase wallet backups. I'll probably just leave that. This. Move. Trash. Ebooks. Google Photos. 6. HDD clone manual. Oh, I did have the manual for that. IQ recordings. 90 megabytes. I don't know what that is. This is one that's debunking fucking the ketone diet or whatever. Why the fuck did I save it all here? Fuck is getting them all?
So I'm just gonna put.
Old. Well, that's just a picture. It doesn't really help me any. Logo has nothing in it. Cool. Important. Glad that has nothing in there. Pretty sure I can remove all these. Oh my god, there's so many fucking random shit in here. Untitled documents. Let's go ahead and remove them. Oh, it's a fucking public key and private key for something. SMS. Oh, these are all my fucking text messages. Cool. All right. Holy shit, something I made in 2010. Oh. Why has this not been updated since April 12th? It'd be every single day that it backs up. Okay, this one was March 31st. Okay. And that's not any better. PSN-US. What the fuck is he accessing on the PlayStation Network? 10.8.20.101. It's on my parents' house. Just using a PlayStation. When was this? 4 o'clock? 2100 hours. Isn't that right now? Um, 30. Diagnostics. HCP leases. Panasonic. What fucking Panasonic device? That's accessing the PlayStation Network? Huh? Hmm. Alright. I'm gonna hop off. I think I've done enough for tonight. I'll catch everybody later.